Manufacturing can be a complicated and overwhelming process, and a big part of that process is taking risks. But nobody said that you had to do it alone.
I'm Jonathan Asparty, President and CEO of Laval, and I'd like you to have a look at the people and the practices that have helped make Laval a leading compression mold builder and composite part solution provider in North America. Let's go have a look.
Founded by my father in 1975, Laval remains privately owned and is a full-service composite parts supplier. Our team of highly skilled professionals will walk with you step by step through the manufacturing journey, from concept to completion. This has been something instilled in us from the beginning. One of the many things that sets us apart are the connections we make with our clients. Laval's commitment to getting the most accurate part for our clients and reinvesting in part production technology gives you a competitive edge. Our Innovations Division is committed to the prototyping process, offering turnkey solutions from tool sampling, equipment commissioning, and full-scale production if needed. Having open communication with our clients and our suppliers is paramount. As a company, we're dedicated to the production processes with aggressive pricing, the best quality results, and in the shortest period of time. This is how we guarantee production-ready molds and parts.
Manufacturing is complicated, so you need a partner you can trust. That's Laval.
Find out more about us by visiting lavaltool.net or give us a call today. We look forward to working with you.
Okay, hi everyone. Welcome to the construction breakout session. I'm Kristina Urquhart. I'm an editor and journalist with a background writing about automation and construction, and I'm going to be your moderator for the next 45 minutes. I'd like to say thank you to Invest Windsor-Essex for hosting us today and to the team that put the conference together. I've done a few of these online events myself, and I know how much work goes into it, so thanks on behalf of everyone here. With me today, I have our presenters for the session. We have Brent McPhail, CEO of Brave Solutions, and Eric Parker, Technical Sales Engineer with Vista Solutions. Thanks for agreeing to participate today. We're about to hear separate presentations from Brent and Eric about some of the innovative solutions they've come up with for the construction industry. This is meant to be an interactive breakout session, so we encourage your questions. Please use the Q&A tab to ask questions throughout each presentation, and we'll leave a few minutes at the end of each one to answer those that come in. So we're going to kick things off with Brent. As I mentioned, Brent is the CEO of Brave Solutions, a control systems integration company that prides itself on solving tough challenges for Fortune 500 manufacturers across North America. Over his 20-year career in manufacturing and automation, Brent has consistently delivered success for his customers by seeking out developing innovative solutions that combine technologies and best practices from across many competing industries. And when Brent is not driving innovative solutions for Brave, he's out on the track driving Formula Ford race cars. And that makes a perfect segue into today's presentation about what snowflake manufacturing is and how the flexibility that we see in automotive manufacturing can work in the construction industry. So take it away, Brent.
Oh, thank you very much. And just really quick, presentation is about 15 minutes and then leaving time for questions. Is that right?
That is right.
Okay.
I'll pop back on at the end. So
great. Okay. I'll share my screen, and I'm really excited to share some insight into the construction industry that we've been up to lately. And it's what we call snowflake manufacturing. It's a new mindset for manufacturing. So about 3 years ago, we were approached by a client to build a machine to help them build hotel rooms in a factory. That was the scope at that time. And at that point, we were really new. We'd been working in the automotive industry, didn't know much about construction. And so what I always say is that computer-controlled automation has been around since the 1960s with the adoption of the first robots into GM's assembly line and first programmable automation. But when you look at construction, the adoption has been incredibly low. And so I used to joke in my early days with the construction guys and I just say, like, obviously you guys don't want to save time or money or be safer or do any of the types of things that, you know, we know that automation can do. But of course, that isn't the case. They've been desperately wanting that and they've made attempts at it. However, they just haven't found a way to adopt it. And so what the challenge of the situation we're in right now is that we have an unprecedented skilled trade shortage. So the average age of a master electrician in the United States is approaching 50. The average age of a master plumber, average age, is approaching 50. And so we also have on the other side of that an increasing demand. So, you know, affordable housing is a global crisis right now with infrastructure spending on hospitals, you know, with COVID. So what can automation fix in the construction industry? Well, the labor availability, quality, and quantity. As I say, robots are going to replace one single construction job. They're just going to enable people to be able to keep up with the demand. And so the demand increase for affordable, sustainable buildings, sustainability. So an interesting fact is every 4 buildings typically that you build in construction, you throw one in the garbage. And that's because of the incredibly high scrap rates. Productivity is systemic throughout construction, and then there's a quality issue, a lot of rework, and a lot of waste and scrap. So there's certainly all kinds of opportunities that we know from lean manufacturing principles in traditional manufacturing that can be solved. So as I started to look at this problem, I love this quote, and I'm sure all of you have heard it. Henry Ford, a customer can have a car painted any color as long as it's black. And the point that I'll make here is that in 1913, in Henry Ford's first moving assembly line across the river, this is how it looked, and this is how he made his cars. And if you look at 108 years later at the Ford Dearborn truck plant, effectively, we're still making cars the same way we have for 108 years. Now, of course, there's lots of automation and there's lots of machinery and processes in place, but all in all, we're making them the same way. And interestingly, the most innovative man on the planet, who is the first new car company to go public in over 50 years, he is still effectively building cars the same way that Henry Ford built his cars back in 1913. And so when you think about automation and you think about traditional manufacturing, it's because we're making a product, and this is sort of our methodology. So how I try to explain this to people is what I call the F-150 story. So the F-150 is a very sophisticated piece of equipment, and you can go to this online configurator and you can specify a whole bunch of different options. And there's probably thousands of different combinations of these options that you can put together. But there is one thing that is always true before you build a line to build 1 million F-150s, or one every 54 or 52 seconds, whatever it is. And that is that each and every one of the options of that truck are 100% known before you build a line to build 1 million of those trucks a year. So this is the rule of all types of manufacturing as we know them today. When we call flexible manufacturing in our traditional manufacturing facilities, what we're really talking about is business case flexibility. So you have an F-150 and an SUV, and maybe you can run those on the same line. You select what you're going to run, all your tooling changes, but what doesn't change is that product you're making is known ahead of time. So now let's talk about what we call snowflake manufacturing, and why I'm saying automation for construction is a paradigm shift in the way that we're thinking. And so when you look at these buildings, you've got a hospitality or hotel, you've got a multi-unit residential, you've got a Starbucks, and you've got a hospital or long-term care. And so each of these effectively is the same. If you were an astronaut, or if you were an alien, you came down and you looked at these buildings, you'd say they're the same. But in the construction world, they're vastly different. And so what we call is our snowflake manufacturing is that, we were first awarded this project to build this machine, and there was about 150 different modules that needed to be put in there. And so as we looked at it, we said, it's a lot, but 150, that's not, we've got recipe-based programming, we can do this, is no problem. And so midway through our design, the customer came back to us and said, "Great news, guys, we've won another building." And we said, "Oh, that is great news. Like this, you're really going to help your business along here. That's fantastic." They said, "Yep." So as soon as the architects are done designing that new building, we'll get that over to you guys so that you can make sure it works in your machine. And that's where all of our guys in our office stopped and were like, "Wait a second, it doesn't work that way. You can't design a thing to work in the factory when that factory is already built." Like when you look at the automotive industry, they spend hundreds of millions of dollars to do tool changeovers and things of that nature. So this is when the weight of the challenge in construction hit us, and that is architects care about they care about the structural integrity, they care about the space usage, and they care about putting their own footprint on it. But they don't care about making things look the same or fit the same so that they can be put into automated machinery. So we had to come up with a new way to do that. And so this is what we call our CAD to fab technology. So it's our robot-driven parametric design solution for precision automated fabrication. And as it turns out, it has much greater ranges than just the precision fabrication as we're finding with other clients. But what you do is you start with the architectural drawing design of the building. So they'll call that their digital twin in their world. And then what happens is you produce a shop drawing out of a CAD package such as Revit. And so that Revit model has positional data of where things are to be located. In our world now, we've created a digital twin, and that digital twin takes the parametric data and it uses it to set up the fixture. So initially we'll create a set of constraints that say, between mins and maxes and spaces and whatever we think the business rules are. And so we set up those constraints. And once we have those constraints, the designers design within those constraints, but have the flexibility as things are changing, much like the way a CNC works, except extending it beyond the CNC environment and the control environment of the CNC to a world where you're using robots and fixtures and different fastening techniques, whether it's screwing, nailing, gluing, welding, riveting, clinching, whatever it may be. And so then this digital twin is a digital twin of the actual piece of automation that has been built. And so the programs are now executed to set up the fixture, to assemble the fixture, and then to fasten it together with the robots. And so here's a real world example. This is St. Clair College. This is the piece of automation. This is the modules being built further down the line. And then here they are being stacked up in this application. And so this is sort of the real world application of this thing coming to life. And so now what I'm going to do is show a video of the machine working. I'll see if I can mute it. Let's go. And I can talk through it. So what you're going to see in here is the robots are first putting some tooling on there to adjust the various spacing. And then you'll see the robots doing some tool changes, grabbing the materials, putting the materials in, and then they begin welding them together. And so the biggest advantage to this is in a traditional work like this, every time a product would be changed, the engineers would have to come in, build new tooling, reteach the robots, reprogram the cell. And in this situation, once this is done and once this has been set up, the architects can change the configuration of what we're building, and the robots automatically go and reperform their tasks. And so some of the definite challenges that we're faced in this is, robots were always designed to be a product that you teach. So the precision of that robot isn't necessarily as crucial as the precision of a CNC, where a CNC goes to an XYZ position and it always goes there. What this was a, this is a, oops. There we go. So what this is this is sort of hacking in a way, but enabling these robots to be incredibly precise, to be within 0.2 of a millimeter to produce the weld accuracy, and then to be able to receive their programming in a different way. And so what I'd like to talk about now is this is our solution for the construction industry. And so we're using CAD to Fab now for copper cutting, for wood fabricating, for other methods of steel fabricating in both 2D and cylindrical. Anywhere that you have a high amount of flexible inputs, where you have to design a fixture or a machine that is going to, someone's going to change a design. Like an example is in the utility poles. So, you've got a changing landscape of elevations and you want to keep your wires at a certain height. So all of the bracketry and all the things that are welded to these high power utility poles are always coming from a design in a different location. And so our CAD to Fab technology is excellent for taking that information, saving a whole bunch of setup time and welding time. But what I want to talk about now is, in the late 1970s and early 1800s, there was a body and a carriage, and that's what became a coach. And so you had the craftsman who would make the body, the wheels, the structure that would carry the things around, and then you'd have the artisans that would make the various carriages. And so I feel that with this level of flexible manufacturing and what we're starting to see in a lot of industries right now, which is people want customization. If you just look at it simply from a paint color, that's a very simple way that they can do this. But I believe it gets to a point at someday where, Louis Vuitton or Nike or, somebody is going to say, I want to build my own carriage to run it on an assembly line. And so think of what that would mean today. You go over to the Ford plant and say, hey, I've designed this new pickup truck. I just want you to run 20 of them. Could you do that for me? They would look at you and they'd think you've had, a third eye. But what's happening right now with companies like Rivian, Rivian is making this skateboard, and the skateboard is the powertrain underpinnings of a vehicle. And so at this level, large companies are investing in Rivian, taking that skateboard, and they're making their own electric vehicles. But what I can see in the future, if we can continue this flexible manufacturing and the snowflake manufacturing ability, is that we're going to give these other big brands the opportunity to take what the the craftsmen are doing and become the artisans and merge the stuff together. And of course, this is a far off future look, but I believe that the things that we're doing today in manufacturing for construction, because that was the difficult challenge that couldn't be solved because we didn't have the technology, is going to circle back and it's going to hit the automotive industry. So I'm not sure exactly how I am on time, but that is what I've got for my presentation right now, and I'm open for any questions.
Great, thank you, Brent. That was great. We do have about eight or so minutes, so we will take some questions. If you want to use the Q&A tab to ask them,
sure.
we can.
I'll just stop sharing here so I
sure,
can.
No problem. I'll kind of get things started. I mean, you talked about with automotive manufacturing having to know each option before you build a line, and the snowflake manufacturing or the CAD to fab solution being sort of an evolution of that. You were talking about using it for cutting applications. Say, what's involved if, say, the client all of a sudden decides that they need to fabricate a different type of piece altogether that's not the same technique? Say it's not cutting well.
Yeah, so there is a limitation to what we are capable of. So basically, the buzzwords in construction right now is design for manufacturing, DFMA. And so what we say is that there's a next level to that. So they're just talking about how can their designers make a building or a product more friendly for their own builders to build. But as we know, humans are the most flexible robots that there ever have been. And so as a human, we can find a way to get it done. As a robot, if we decide ahead of time that robot is going to be of a certain size, and now you create a hole that robot has to go in that's smaller than that size, it's not possible. And so we're living today in a constraint-based system where we have to, initially set up what these constraints and limitations are going to be, get agreement upon them. And then what we can do is we use our digital twin where they take their shop drawing, put it in the digital twin, and we run a validation check. So we're trying to prevent them from getting that down to the floor where they have to learn that, maybe they can't automate 100%. They can only automate sort of 70% because some of the rules have been broken. And so we give them a validation check at that stage that they can then go back. And a lot of times with the architect, they will say things like, okay, I didn't need to use my structural supports in this way. I could have also done them this way had I have known that would have been an issue. So that's sort of our early stages break fix approach to the design for manufacturing challenge, which is an interesting, you would never have an automotive designer design a pickup truck without putting all of the location points and things. Like if you take the skin off of your off the door, there's a bunch of holes and pins and things behind it, and you wonder what those are. Well, those are designed for manufacturing, but in the automation for construction world, we've got, and that's a tribal knowledge that's passed down in automotive, but in the construction world, we've got, 5 years. We don't have a generation or multi-generations to train a group of architects. The other challenge is architects don't sit under the same roof as the GCs and the builders. So in Ford, you've got a little more control because your designers work for Ford, your manufacturers work for Ford, and you've got this a little bit of more continuity there. So it's a huge problem for these design changes, and all we're trying to do right now is sort of pick the lowest hanging fruit, which is proving to be a monumental task even at this stage. Right? It's very early.
Yeah. I mean, this term snowflake manufacturing, I really like it. You talked about that prefabrication piece, but where do you think that we stand in the construction industry when it comes to other types of automation being used for, say, on-site bricklaying, painting, that kind of thing? Like where do you see the evolution going?
So what we're kind of identifying are 4 verticals, and the vertical that we're attacking right now is what we call the offsite manufacturing. So the address of where it's being built is different than the address of where the building can end up. But another one is, yes, exactly as you said, it's like, what is the on-site versions of that? And so as we're doing more digging, we've got a client right now that they're building battery farms. And so these batteries are heavy. They have to be installed at the point of contact. And so, I mean, these are huge challenges to help them in harsh environments. And it's a complete different mindset. I was touring a job site a couple of weeks ago, and the things that we don't understand in traditional manufacturing, a truck came in with a trailer. It was a muddy, rainy day. It was in North Carolina. And we're sitting in our car waiting to get out. And this truck is now blocked up the entire road in and road out. And so we sat there for 25 minutes, unable to move because a truck had come in that couldn't back out. And so these are the challenges we don't have to face in a in a manufacturing environment. So as we gain our domain knowledge and we understand the openness and the difference of that manufacturing environment, then you're seeing, tools and assist tools and things of that nature being put into place. So, and there are some examples out there of the bricklaying machine you can see on YouTube and things of that nature. At this stage, a lot of it's gimmicky, but it's also sort of the first step of it moving towards something that's not gimmicky, and there's a huge demand for that.
So, I mean, as automation and construction increases, like, we're going to need workers to be able to maintain and operate this kind of equipment. As CEO of an automation company, I mean, where do you see the role of automation companies in terms of educating clients, educating people about, these jobs that need to be filled?
So there's jobs that need to be filled, but the biggest thing that we're finding is that a lot of construction companies that do have offsite manufacturing, they are basically they're just manufacturing their on-site processes in an offsite way. So they're just now in a climate controlled environment in most cases. They don't understand the manufacturing organizational structure. They don't understand the process engineering, industrial engineering. Another big one is material planning and logistics, which is crazy because all a construction company does is material planning and logistics. But it's different when it's in a lean environment and in a manufacturing environment. So, one of our first challenges is to not hand the keys over to a piece of automation that is too complicated for the particular client. And so we have this industrialized construction maturity assessment that we'll do. And so we'll help find out where they're at, show them what their gap to good is, show them how we can get them to a situation where they're now suitable to be able to, so we can start with something very simplistic and move them up. And we found in the past that has been a failing of ours, is that we build these ultra super sophisticated systems that, an auto plant, which is full of engineers, has no problem dealing with. And a construction company goes like, why did you give us this? Like, we're not ready for it. Right. And we're sitting there going, no, you're not. Oops, we're sorry. How can we help you? And so this is what the challenge is that they are so, because of the labor shortage and because of the demand, the ROI and the opportunity is there, but it does not mean you'll have a successful project just because of that. You've got to really try to help hold their hands.
Right.
And they've also got to be willing to take the medicine. And so part of what our job is now, as we're doing our business development and finding new clients, is stepping in and saying, hey, you got to be able to check your ego. You got to be able to take your medicine. Here's how we can help you. Here's how you can be successful, but let's not go down and make these mistakes that have been made in the past.
Yeah, it's a long road, pun intended, I guess. So thank you, Brent. We're gonna wrap it up there and move on to the second and final presentation, which is about a road project. So we're gonna hear from Eric Parker, who has spent the past 3 years as a technical sales engineer with Vista Solutions, an advanced engineering and technology company headquartered in Windsor. Eric is responsible for developing business opportunities with both new and legacy clients across Canada and the US, as well as generating and executing sales strategies within Vista's North American sales team. He has a background in software and product development, and that serves him well as he helps to put together proposals for vision solutions like the one he's here to talk to us about today. It's actually for a pretty neat custom solution called the Robotic Maintenance Vehicle, or RMV, and it's used in road construction, as I mentioned. So to our audience, if you have questions for Eric throughout his presentation, please use the Q&A tab, and we'll answer them at the end like we did with Brent. And Eric, I'll let you take it from here.
Thank you, Kristina. Happy to be speaking this morning. As you mentioned, today I'll be talking about Vista's Robotic Maintenance Vehicle, or RMV, and this is a solution for the road maintenance industry. Brief background on introduction for Vista Solutions. We were founded in 2003 and maintain a 100% business and technical model focus on the development and integration of machine vision and automated imaging solutions. As you can see in lots of different industries, very diverse experience there. We're also a technology agnostic company by nature, meaning we work with all different camera technologies, 2D and 3D, different vendors, different software technologies as well. And ultimately, we're expert solution providers based on commercial technologies. 5 locations across North America, proudly headquartered in Windsor, Ontario. And we have very world-class machine vision lab facilities. And this is one of the main elements that makes these types of research projects successful. I'll get a little bit more into that later in this presentation, but we are constantly and heavily investing in cutting-edge resources and machine vision equipment. This plays a key role in our success. So that headquarters is in Windsor and different locations across North America, United States, and Mexico. To give you a glimpse at our customer base, so this is a lot of our global Fortune 500 companies. As you can see, many household names, diverse customer base, and spanning many industries as well. We also maintain very strong collaborative relationships with other automation partners. I show this slide because this represents 8 of the largest automation companies in the world. And we act as a subject matter expert in the field of machine vision for these companies, as well as many, many more mid to small size automation companies. So we certainly play well with others in a very non-competitive manner, and we're no stranger to collaboration. And that is true for this project as well. So what you see here is the robotic maintenance vehicle prototype. And what this solution attacks on the head basically is automating the asphalt and concrete sealing process. So as you can see in this picture, bear with me. I'm sure many of you have seen on roads, these sort of black stripes that occur. And this is a very common road maintenance strategy that's done by many municipalities across North America and the world. And RMV looks to automate that process. So this was a collaborative effort between 4 different organizations. First is Pioneer Industrial Systems. They were our mechanical design and robotics partner. Necotech is our Department of Defense and Federal Aviation Association partner. So you might wonder what aviation has to do with this product. Well, as you can imagine, while this is a useful solution for city roads, it's also a very useful solution for airport maintenance. And so there's been a lot of interest on that front, and this has been spearheaded by Necotech. Sealmaster is a franchise supplier of sealant equipment, and they are the supplier of the equipment in this case. And of course, Vista Solutions' role as the intelligent vision system and robotic vision system guidance solution. Touching a little bit on the business case here, 3 major elements that make this compelling. First and foremost is road crew safety. So safety is a big issue within the road construction industry. In the United States alone last year, 123 fatalities occurred and many, many more substantial injuries as a result of road crew operations. Hand in hand with that is these processes are currently very manual. And there's high costs to manual labor associated with it, as well as insurance having to do with the safety piece. So currently a standard crack sealing road crew is a 4-person crew, and RMV is looking to reduce this to 1 to 2 people, depending on the conditions. There's also a lot of added costs introduced by operator subjectivity. So as different operators use basically large amounts of material, bringing objectivity to that process will bring cost savings as well. A last major factor here too is speed. So an experienced crack sealing crew can do about 2 miles of road per day. Due to the increases that we can achieve with the robot and the reduced downtime as well, RMV is striving towards 6 miles per day. Additionally to this, the market is very substantial. So 2,600 counties across the United States, many of which do very high volume road maintenance, meaning they have a use case for multiple road crews or RMVs. There's also no competitive solution that currently exists in the North American market. Take a moment here to introduce Vista's 3-step approach to solving difficult machine vision problems, and it all has to do with risk mitigation. So it's very common for Vista to perform evaluative engineering studies in which we assess whether or not machine vision projects are feasible. That is how this project started. Essentially the concept is customers bring their problems to us, and our approach is image and then analyze, then automate in that order. And the benefit of this is we look to test and address the high risk elements of the project before committing to the large capital or development expenses required for a final production system. We're able to achieve this because of a substantial investment in our lab facilities, because we have access to a lot of this capital equipment on hand for these evaluative purposes. It's basically the labor cost to do the upfront testing. And in general, what this means for a customer is an engineering study typically costs them about 5 to 10% or less of what the value of the entire project would cost, but they learn a very great deal from it, typically mitigating about 80 to 90% of the risk with that first phase. For the RMV project, what that looks like is, here I show what the test rig looks like. The actual vision equipment in this case is shrouded by this cover here, and you'll see the impact of the shroud or the use of the shroud in the prototype as well. But essentially, we built a test rig, came up with the right imaging solution, performed a lot of different analysis and tests on varying road conditions and anomalies across many different types, and basically wear levels of these different road surfaces. Through that phase, we did achieve success in a variety of different ways and moved on over to the prototype. And I'll show a little bit more about the prototype in a moment, but there were a number of technical challenges that were overcome along the way. First is we needed to come up with a solution that handled both asphalt and concrete in outdoor conditions, so lots of variation to the environment. Additionally, crack sealing is currently a very subjective process. So, whether or not operators are filling cracks, a lot of nuances to it. Cracks are very random in shape and structure, and the widths and depths are not reliable and necessarily continuous. I mean, as you've seen roads, that virtually anything goes, versus manufacturing environments where there are a fixed number of part types, such as what Brent was mentioning. Variation is endless, and that creates a lot of complexity and challenges within the machine vision algorithms. We also need to do this at speeds capable of achieving our objectives. So in our case, this means about 2 miles an hour. The margin for error, while it's not, extremely tight sub-millimeter, it's still very difficult when you take everything into account. We're looking to, essentially align a puck that performs the crack sealing over these cracks. We also have to consider the robot guidance accuracy elements of the project, as well as vehicle drift and compensation associated with that. So here's what the vision system looks like now. So underneath this hood, you have the shroud that basically protects the vision system from the environment, as well as creates controllable lighting conditions. The algorithms that we use are a combination of traditional and AI-based inspection techniques for crack finding. And a lot of the complexity comes with calibrating the robot and vision system coordinates together. It's the vision system that actually develops the optimized path and tells the robot where to go next based on its previous location in order to do that in an efficient manner. It's also the vision system that's responsible for the vehicle motion tracking. This is both in the longitudinal and transverse directions. And we do need to constantly monitor this as the vehicle continues traveling, because the vision system and the robot aren't in the same physical location. So now I'll play a little video here just to show you the RMV in action. I'll say this, this video was taken during more initial prototype testing, so much progress has been made since to improve crack sealing abilities, as well as robot speed and path efficiencies. So you can also follow the story as well. Basically, we regularly post updates on rmv.llc. This is the prototype system number 1, and ongoing system improvements are occurring every week. So, there's existing 33 chapters on the website, and we're frequently posting additional chapters. There's also a mailing list that you can join as part of this. So if you do have an interest in following the development story as it continues along, this is the best way to do so. So, just kind of switching gears a little bit here. RMV, represents a very difficult machine vision problem. Virtually endless road variation, lots of subjective crack sealing methods that we're trying to emulate. But we've demonstrated success through our phased approach, and we can do this for your process or inspection requirements as well. We develop custom proof of concepts for many different machine vision applications across many industries. And the core of our business is deploying custom inline automated machine vision solutions for these applications. So if you have any applications related to measurement, identification, inspection, or vision guided robotics, these are our areas of expertise. And this is an example of a product solution that came from our development team. Lastly, have a very flexible business model. The core of our business is supplying and integrating machine vision hardware, but we work all the way up to full turnkey automated solutions such as RMV. And we built the right partnerships across many different industries in order to take your project through completion. Wrapping up here, there's a number of reasons why you should consider working with Vista Solutions, but primarily we're a recognized North American leader in machine vision integration, and we have the right technical approach, investment, lab facilities, and technical talent in order to conquer your difficult machine vision problems and make your vision project a success. Thank you for the opportunity to speak about our RMV product, and feel free to reach out directly with any questions you may have.
Perfect. Thank you, Eric. Appreciate that. Just a reminder, if you've got any questions for Eric, please drop them into the Q&A tab. We have a few minutes here before we send you back off to see the keynote. So Eric, I'll maybe ask you, what's sort of the next step for this prototype going forward?
Yeah, so we have prototype number 1, and we've done a number of tests and continued improvement. The next phase would be entering a beta phase where paving contractors have these units and are trialing them and their performance on roads that they're contracted to repair. This is already something we've done in parking lot capacities kind of thing. But the continued work on actual road environments, gathering all more information to make our algorithms better is kind of the next step there.
Mm-hmm. And then, as it starts to roll out on a larger scale, do you anticipate this being an off-the-shelf solution, or, customizing it to fit each client's specific needs?
Yeah, so the plan is for it to be an off-the-shelf solution. So we do intend to continue supporting this. We expect, this very similar to, any software application that you have, like Microsoft Word or things like that, are developed and have more features over time. So that's kind of the capacity that we're bringing this to market at. But, in the events that the right business case is there and, custom development is required, that those are services we also provide.
Okay. So I'm curious if there's any type of asphalt terrain that wouldn't be suitable for this kind of solution, because I'm looking at the hood or the enclosure's height off the ground in that video.
Yeah. Well, in general, the enclosure, like basically the truck height is altered by the actual chassis, basically. So you kind of saw in that video, they were lowering it down into the imaging position, but during transit, it's a different story. Mm-hmm. The bottom of the enclosure has been designed for to be flexible, basically. So we have seen curvature in road, we have seen all sorts of those conditions, but ultimately the goal is to have the solution work on all different types of road surfaces, and that's kind of the difficulty of the problem too, differentiating cracks on all surfaces.
Mm-hmm. So how do the differences in the road surfaces or even the road conditions, like wet versus dry? How does that affect the vision system and in terms of how it displays information?
Yeah, so you know, basically road is conversely to manufacturing environments, where you're going to have a specified number of products with exact, you know, more or less visual characteristics. The appearance of the product in this case, which is the road, changes a lot, even compared to, you know, food products as an example, which we think might vary a lot. But that's kind of the primary challenge of this whole program is handling that variation. And that's been where a lot of the complexity is introduced into these algorithms. So, you know, we've systemically come up with methods to collect more images of different road conditions, bring them into consideration, and then track progress on how we're doing. And that process continues with development and will likely be ongoing for a very long time.
Okay. And then just to kind of wrap up here, I mean, you talked about, you know, RMV being just one example of what Vista can do. I mean, what about other projects? How can companies, especially those involved in construction, best engage with Vista when it comes to what they need for vision and inspection?
Yeah, so I mean, we work in many different industries. We've done proof of concepts in you know, construction, mining, logistics, all sorts of different environments. The first step is getting in contact with us, defining the problem. So if you know, if you think you know exactly what inspection or vision guided robotic process you're looking to implement, understanding what the problem and the goals are and communicating those to us, we can come up with a phased approach that makes sense. So we've done lots of these engineering studies, as I mentioned. You know, some of which are single phase and then development. Some of which are a multi-phase development, hitting all sorts of different risk items and learning a lot along the way. Mm-hmm. So I'd say, you know, reach out to us and, you know, we can figure out a phased approach that makes sense for you.
Sounds good. Just quickly here, I've got a question about safety guarding and area scanners. This audience member is asking if they were quite difficult to get them into a sort of safe configuration. Are you able to quickly comment on that within 60 seconds?
Yeah, I can. So the design of the actual mechanical and safety was under Pioneer's boat. So I'm probably not the right contact for this, but in general, I know we designed basically to manufacturing standards. So there's all sorts of safety standards on those yellow gates that, you know, physical barriers as well as software barriers and hard barriers for the robot's position, essentially. So there's all sorts of sensors that form the primary, you know, operator safety element of this. Before we could even do any of the vision algorithms.
Mm-hmm. Okay. Well, great. Thank you so much, Eric. Appreciate your time. Brent as well. Thank you for your time. This went by quickly. Thank you to our audience for the questions and for participating. From here, you can click the stage tab on the left of your screen to get back out to where the keynote is going to be. You're not going to want to miss it. Jim Beretta is a dynamic speaker. So that's all we've got for construction. Thanks again.
Thank you.
All right.